Hello and welcome to the fourth part of this video series. Today we will start our discussion with OFDMA. So basically OFDMA is used in the cellular world in order to multiplex multiple users in the cellular spectrum. And when I say cellular, you can think of it as LTE or 5G spectrum. Okay, so Wi-Fi 6 as a part of its enhancement in order to enhance the efficiency, it brought or borrowed the OFDMA Wi-Fi or the channel access method from the cellular. So based on this fact, we can safely say that Wi-Fi 6 operations at the PHY layer is cellular lookalike one. Now, before we start and dig deeper into OFDMA, we mentioned here the following topics. So we mentioned, for example, OFDMA, which is the main topic. Also, we mentioned cellular or LTE or 5G. Our main topic in this series is Wi-Fi 6, and pre-11ax we actually used Wi-Fi channel access method known as OFDM. So before we start, let's try to let's say on high level to compare and understand the function and the differences between them. Okay, so let's bring this table. It compares the OFDM and OFDMA. So both of these methods are channel access methods that separate users in time domain for OFDMA or for OFDM, whereas we separate the users in frequency domain in OFDMA. When I say time domain, imagine this like if I have multiple users, I give user 1 a time to send its data, and once that time expires, then we thank the user and give another time ticket, let's say, to the next user. Whereas in OFDMA, if you remember, we classified the spectrum into RUs, and instead of giving access tickets to the users in sequential manner as this one, we assign smaller chunks or RUs to multiple users at the same time, and they can transmit their data. So in OFDM, all subcarriers within a symbol are actually assigned to a single user at a time, whereas we have smaller frequency chunks with subcarriers, not all of them assigned to separate users at the same time. Therefore, based on what we have discussed here, we can say that OFDM is a static channel access method. Why it's static? Because there is no intelligence behind the decision used to assign the frequency to a user. Whereas the OFDMA can be viewed as dynamic channel access method because of the enhancements that we have discussed and the support of multi-user operation. So the synopsis here, we can say that OFDMA equal multi-user version of OFDM. That is the synopsis here. Okay, what else we have? Okay, on high level, let's compare Wi-Fi 6 or Wi-Fi in general with LTE slash 5G, or let's say cellular in general. So basically, the access or the access to the medium within Wi-Fi is contention based, whereas in LTE it is centralized based. Okay, so now contention based, you remember that each station in a Wi-Fi channel has to LBT, listen before talk, and the politeness that we already talked about. So it is just like it is viewed just like if these users are contending between one another to access the medium and push or transmit their data. So who does that? Actually, it would be the protocol. So each one within the cell obey the protocol. So someone would win the access at a certain time. So you can say it is completely controlled by a probabilistic approach or randomness. Whereas in LTE, which is actually a proficient or an efficient protocol, the channel access scheduling is actually done by the base station. So regardless if you are in 3G network, the base station is called base station or BSC. I'm just mentioning for your reference. In 4G networks, this one is called enhanced node B, node B. And in 5G nowadays, this is called G node B, G node B, which is next generation node B. So actually the operation here, just to make it, let's say, more obvious for you, in Wi-Fi 101, we studied DCF, which is distribution coordination function. And also there is PCF, which is, I think, PCF, which is point coordination function, in which the access point actually takes care of scheduling the access and devices turns to the medium. So you can just, it's totally different, but just a procedure that PCF and LTE or cellular are actually the same in a way or another. Okay, now in OFDMA, the actually scheduling and the channel access and the assignment of resources is done on per frame basis, and that is in Wi-Fi, whereas in cellular it is done on time-based basis. So for example, you have your mobile phone, iPhone or Android, you insert the SIM card, you assume access to the LTE or 5G network. Then the base station assigns actually you one time the frequency resources that you are going to use until the lifetime of this session. Whereas in Wi-Fi, it is done on per frame basis. So each time the access point is going, for example, to send or receive a frame, there should be massive scheduling and processing done before that. And we already mentioned something about this. It is related to AP scheduler function. Okay, so the best scheduler efficiency is found in, let's say, the best access point that can provide Wi-Fi 6 functionality. So you can actually evaluate vendors like, for example, Mist, Aruba, Cisco, etc. Let's say based on the efficiency of the access point scheduler. Okay, The last item to compare here is that in Wi-Fi 6 we use 1024 QAM, whereas in LTE or cellular we use 256 QAM. Okay, let's clear things up. Continue to the next section. Okay, so now assume we have 3 users. Let me grab my pen again. Each one has, let's say, a data to send to a server. Okay. And we would like to compare this between OFDM, the old method or the pre-11AX operation, and the 11AX. So now I have 3 users. If I want them to transmit at the same time, previously the only solution is to have one access point per client so that they can transmit uplink at the same time. Or we can follow this approach. For example, we can have user 1, and let's imagine the truck as the, let's say, the frequency spectrum on which we actually send our data. So what will happen is user 1 will use the available spectrum to transmit the data all the way to the server. After that, user 2 will use the available spectrum to send that to the server, and then after that, user 3 would do the same. So the transfer is done in sequential manner. Now with OFDMA, which is used, or the main enhancement that let's say contributes to making Wi-Fi 6 more efficient. Wi-Fi 6 actually, or OFDMA, looks at the empty part of the glass within the spectrum. Okay, not only actually to criticize that as we do in our conversation, we just look at the empty part of the glass just to criticize, but OFDMA looks at that in order to think of a way on how to reuse this for other clients to allow them to transmit at the same time. And actually this is a paradigm shift in Wi-Fi channel access, which contributes to the Wi-Fi efficiency that we talked about. Okay, so by this example, we can see that we can put the 3 user data in one transmission and send it all the way to the server. Okay, let's clear things. Now I actually included this table here. We already discussed about it, but I wanted to include it for your reference because it shows the relationship between the RU size and the number of users that we can support per channel bandwidth. So for example, in 40 megahertz channel, while using, let's say, this RU size of 106 subcarriers, we can support up to 4 concurrent users at the same time. So have a look at this. If you have any question, let me know in the comment section. Now, OFDMA actually improves efficiency, but not necessarily improve the throughput. Why is that? We already discussed this in the first video. Wi-Fi 6 was designed for high efficiency. Wi-Fi 7 is designed for extreme high throughput. So we mentioned here that it's not necessarily to improve, but it might improve. But the main target of Wi-Fi 6 is the efficiency. So there might be throughput enhancement, but it's not the main target of Wi-Fi 6. Throughput could be a byproduct of the efficiency that Wi-Fi 6 has introduced. Okay, now when we talk about OFDMA itself, we have two types of transmissions. We have the downlink OFDMA and uplink OFDMA. Let's have a look at each one of them in more details. Okay, so let's start with uplink OFDMA. When I say uplink, then it is or the direction of traffic would be from the users to the access point. Now, assume I have these three users connected to the access point, and this one is located at the edge of the cell. Okay, this one in the middle between the edge and the access point, and this is sitting under the access point. Okay, now if we want to do a multi-user uplink transmission, the first question that comes to your mind is, how can we arrange between user 1, 2, 3 to have them all transmit at the same time, or at least within a small tiny time drift between each one of them? So honestly, in order to do this, we have this problem, or we had this problem previously in 11AC. 11AC suffered from, let's say, the process of grouping users together. And now in 11AX, someone might say, oh, we need to find a way in order to coordinate between this user and this user to speak to one another, for example, in order to arrange a timely transmission. But unfortunately, there is no predefined or new procedure for that. So OFDMA, or Wi-Fi 6, actually introduced a new specialized trigger frame. This frame wasn't available previously in 11AC or earlier. What it does is the following. It actually tried to trigger an uplink transmissions, so it contacts the stakeholders that are going to participate in the uplink transmission. Inside that frame, it tells the stakeholders about the duration, the guard interval, as well as the frequency resources assigned to each user, the MCS value that the access point is expecting user 1 to use to send the data, and it's not necessarily equal to the same MCS value for user 3, for example. The transmit power that the AP uses to transmit this frame, and actually the AP mentioned this in order to equalize the power reception coming from all stations at the same time. Because with this value, we can improve the delivery of frames from stations that are far away. So we will talk about these details in the next slide, but the idea is the access point actually triggers this transmission, and as per the protocol between the Wi-Fi 6 access point and Wi-Fi 6 capable clients, all stations in order to achieve this time sync between them, all station has to have to obey the rule of immediately sending their PPDUs after a CIFS. What is CIFS? It's a short interframe space. So this user, this user, this user, all of them will be actually, let's say, instructed to transmit their data instantly after the CIFS expires. As I remember, CIFS for 5 gigahertz, it's I think 16 microsecond, whereas in 2.4, I think it's 10. I don't remember exactly. I don't know what is the value is for 6 gigahertz, but maybe later on we can check that. Okay, so let me clear things because it would be more clear. So now we sent a trigger. All stations will wait for a CIFS, and immediately at the same time or within a small tiny drift in time, these clients will transmit at the same time, and then it will be grabbed by the access point as a multi-user PPDU. So trigger frame actually is used to solve this time sync. Okay, now let's have a quick look at the Wireshark view of an example of a trigger frame. So a trigger frame is actually of type subtype 12 in hex, or you can use 18 in decimal in order to get that in the Wireshark filter. It contains mainly common information for the whole transmission as well as per user information. Okay, let's look into the common information. So basically, in the first place, it defines the trigger frame types. We have, I think, 3 or 4 types of trigger frames used in 11AX. So it has to specify the type here. Also, it mentions the expected packet or frame length that should be received from the multi-users in the uplink transmission. As well as we can see, we have uplink bandwidth used for this transmission. In our example, it is 40 megahertz. This could equal actually to the channel bandwidth assigned to the access point. Also, it mentions or add information such as guard interval and LTF type, the training fields. So the GI is 1.6, whereas we are using 2 LTFs. And by the way, based on the number of LTFs, we can guesstimate the number of supported special streams within this transmissions. It is here. We will talk about it. What else? Okay, the AP transmit power. As we said, the access point clearly mentions the transmit power of the AP that it used to transmit this frame, because the users could use that in order to do some calculations and to equalize the power reception of the multi-user response, which will actually improve the reception of users sitting far away from the AP. Also, we can find information such as special use parameters. We will talk about this later. Now, let's talk about per user info. Unfortunately, in the Wireshark capture I found, actually, we have only one user participating in this uplink transmissions. Usually, if you have, let's say, 4 users, you would find this section replicated 4 times, and it will contain different values per user. Okay, so now the access point in or under the user info specifies the association ID of each user, as well as the resource allocation for that user. Since we have actually only one user, so as you can see, we are assigning the whole 484 tunes to one user. Also, the MCS that the AP is expecting this user to use to send the data, and the number of special streams that this user could use. And the last thing is the target RSS size. So the access point tells the user that I'm expecting in this uplink transmission to receive your packet at RSSI equal nig 64 in our example. So maybe the client would do some intelligence to raise power, etc. And what other information? I think, yeah, that's it about the information that you might be interested within in uplink transmission. Let's clear things. Let's move to downlink OFDMA. So downlink OFDMA is not new. It was there in 11 AC. However, the grouping of users in a downlink transmission was improved. Basically, we have a multi-user PPDU from at the access point. It sends that, and each user will receive its own PPDU. I want you to remember one important thing. HE-SIGB is mainly used in the downlink transmission, downlink OFDMA transmission. It contains common information as well as per user information. Common is related to the whole downlink operation, whereas per user information such as number of special streams assigned to this user, let's say this one, this two, this one, and the MCS coding, etc. Okay, so that's all I have about OFDMA in general in this video. You have to remember that OFDMA introduced a paradigm shift in the channel access that Wi-Fi actually used to, let's say, support previously. So we already discussed about this. I hope you found it useful. If you have any question, please let me know in the comment sections. And let's stop here in this part. See you in the next part, and thank you for watching.